This is Science Friday. I'm Kathleen Davis.
And I'm Ira Flatow. And now it's time to talk aliens. Creatures from another planet are so part of our culture. I love that theremin music from The Day the Earth Stood Still. It's a great movie. And, they appear everywhere, aliens, in movies, books, comics, you name it. And actually, words like UFOs or the modern government phrasing UAPs, unexplained aerial phenomena. I'm still not used to that phraseology. They're both science and science fiction, aren't they, Kathleen?
Yeah, and we have been fascinated with the question of alien life being somewhere out in the stars for decades, even centuries. And so now with congressional hearings into Navy pilots' sightings of strange things, the search for intelligent life is getting a more serious treatment. And so how do we, as a culture, think about alien life with an open mind?
Yes, and joining us to talk about the search for intelligent life and how we might find signs of it is Dr. Adam Frank, professor of astrophysics at the University of Rochester, author of The Little Book of Aliens. He joins us from WXXI in Rochester, New York. Welcome to Science Friday.
Oh, thank you, Ira. Thank you for having me on.
Nice to have you. And let's get right to this flurry of attention that we mentioned to this topic in recent years with the release of those famous videos from the Pentagon. What is your take on those?
Yeah, well, what's interesting about that part of the story is how it also rides on what's happening in astrophysics. And I think they're actually related because we're getting so close to actually getting data from astronomy about life in the universe that I think the UFO and UAP stuff is sort of picking up on that. In the book, I know people are interested in this, so about a third of the book is about UFOs and UAPs. And what happened in 2017 was the New York Times published an article, front page article, about this Pentagon program that was looking at UFOs, or what they were calling unidentified aerial phenomena. And it was accompanied by these 3 videos, which have been replayed endlessly, taken by Navy pilots. And that was the beginning of sort of this flurry of new activity where people were recognizing that the government had an interest in this. The government was admitting that there was unidentified stuff that they were seeing. And of course, if you were into UFOs, you're like, my God, this is it, finally. And if you're skeptical like I am, you're still like, okay, this is interesting. We should study it. But there's still no data even close to associating any of this with, anything non-human.
We are taking calls this hour. Our number is 844-724-8255. That's 844-SCI-TALK. So what would it take to actually be proof, aside from an alien, appearing and telling us to, take him to our leader?
Right. And that's, after 30 years of doing all different kinds of astronomy, everything from star formation to how stars like the sun die. One of the reasons I did this book is because I myself have started doing astrobiology, over the last 10, 15 years. And we are now at the point when it comes to getting proof that it's going to be our telescopes. It's going to be things like the James Webb Space Telescope, and in particular the telescopes which are going to come after it, the ones we're designing now, where we are going to have data. I can't tell you what it's going to say, but actual data, rather than just yelling at each other about our opinions, relevant to this question of, is there life, alien life, where we should find it on alien planets. And that's the game changer. That's why I wrote the book. I wanted people to understand how after literally millennia of human beings arguing about this, we're finally in the position to get real hard data about whether or not we're the only life in the entire universe.
So one thing that I love in your book is that you say that there's one big flaw in this argument of UFOs, those traditional flying saucers, being alien visitors. And you say, if aliens were here and they wanted to hide, that would be a pretty bad way to do it, right?
Yeah. I call this the high beam argument, which people are always saying, oh, I saw these lights in the sky and they were moving in incredible ways. And of course, these aliens never just land on the White House lawn and say, yeah, we're here, what's up? So, they're trying to not be seen, and they're terrible at it, which for supposedly advanced technological creatures, are they sending us their teenagers who are can't find the cloaking device button?
Yeah, of course, you can imagine we have a lot of listeners who want to get in on the conversation. Our number, 844-724-8255. Let's go to Chicago. And Kevin, hi. Welcome to Science Friday.
Hello, how are you?
Hi there. Go ahead.
Well, you know what? I was just, first of all, this has always intrigued me, this subject. And I just feel that we can't be the only so-called intelligent race in the universe. There has got to be somebody else out there, all those billions and trillions, out there in the universe.
Yeah.
You know?
Yeah.
And in the event that I'm wrong, would it be a good idea for us to try to, find E.T., whoever E.T. might be? Depending on their mindset, how would they view us? And you know what? A reason they probably don't land on the White House lawn is because they see how we are with each other.
Okay, let me get an answer. That's a good point. How do you answer that, Adam?
Well, there's a couple parts here. Raised really good questions. The first one is what are the odds that we are the only time in the history of the universe that or any kind of life, but certainly intelligent life formed. And Woody Sullivan and I did a paper on this in 2016. And what we just did is we used the data that existed about exoplanets, because we have found now that the universe is teeming with planets. We didn't know that when I was a graduate student.
Yeah.
And so what we figured out that was there are 10 billion trillion planets in the right place for life to form, what are called habitable zone planets. So in order for us to be the only time that life has ever formed, then, it must have mean that all of the experiments that nature was running with those habitable zone planets failed, if you think of them as being experiments. And yeah, I think I agree that it's up to the pessimists to tell me why it would happen here and it didn't, and why the experiment succeeded here and failed in those other 10 billion trillion planets. That's not a proof by any stretch of the imagination, but it does sort of, I think, shift who has to do the argument about life being common or uncommon. So that's the first part.
So
the second, go ahead. I'm sorry.
Well, are you talking about the Drake equation here?
Well, that's what we did. We modified the Drake equation to take into account, like when Drake wrote his equation in 1961, nobody knew whether there were any planets other than the 8 in our solar system that existed. It was possible that planets were really rare. And I try to cover this, unpack this in the book so people can see how the evolution of our thinking was. So when I was a graduate student in 1986, it was entirely possible that planets were just very, very, very rare, which meant life was very, very rare. And then in 1995, we discovered our first exoplanet, and now we know that every star in the sky, every star you see in the sky pretty much, has a family of worlds. And if you count up 5 of those stars, one of them is going to have a planet in the habitable zone, the Goldilocks zone, where liquid water can exist, and we think that's what's important for life. So much change in just the last 20 or 30 years. The game has changed, and that's why I want people to understand that's one of the reasons why we're so close to getting real data about the possibility of life in the universe.
So in your book, you called the Drake equation, and I'll quote it, an epoch-making milestone. It will be remembered as the moment when it all began. Is it that important?
Yes, it is, because what happened is that for centuries, like I said, you can see the ancient Greeks yelling at each other about whether life existed. And we just didn't have a good way of thinking, even scientifically, about the problem. And it was really this amazing decade of 1950 to 1960 that all the seminal work happens. The Fermi paradox is sort of first formulated. Drake carries out his first experiment. He does Project Ozma and looks for signals of extraterrestrial intelligence, which was really the first ever astrobiology experiment at all. First time anybody looked for any kind of life in the universe. And then what that equation did when he wrote that equation, which was really the agenda for the first SETI meeting ever held. He took this problem that people couldn't even really figure out how to think about, and he parsed it into 7 sub-problems, right? The main problem is how many intelligent civilizations are there in the galaxy that we could talk to? And he broke that problem up into 7 sub-problems, each of which could be studied independently and made progress on.
Okay. Let's go to the phones to Alex in Martha's Vineyard. Hi, Alex. Hi there. Go ahead.
Yeah, I was calling in to mention I'm an anthropologist who studied the UFO topic and aliens and such for maybe 3 decades now. It's always a little disconcerting to me to hear the topic of UFOs and aliens get conflated together. And of course, I do know why. It is the most popular layman's explanation for the UFO phenomenon, but I tend to think that it might actually throw us off the scent scientifically when we do that, when we say these interesting phenomena we see in our terrestrial skies, and we jump to the conclusion of aliens when there's absolutely no proof of that.
Yeah, I agree. I agree completely that they are separate things. And it's, but of course the interest, often when I'm asked to do something on CNN or MSNBC about this topic, it's because people are making that conflation. Oh, the latest UFO video. And then it's like, what does this have to do with aliens? And I always have to explain that there's just no solid data. There's no data of the kind I would be required to provide if I said I found alien life on an alien planet that links UFOs to anything non-human.
So have you seen any compelling evidence, in your opinion, that makes you think that maybe we have encountered some sort of alien technology that we've maybe been visited in our solar system? This makes me think of Oumuamua, which I know some astronomers have strong feelings about.
Yeah. So the answer is no. There's just nothing. Because, I wish that would be the most exciting thing ever. I'm not against it. And in the book, I argue that, look, let's do a transparent, open scientific investigation of UFOs and UAPs and see where it leads. But as of right now, there is just nothing to indicate that we've been visited by anybody. And, so Oumuamua, you bring up Oumuamua, which was exciting on its own because it was the first interstellar comet or interstellar interloper. The first time we saw something, entering the solar system from outside. And of course, Avi Loeb argued that it might be a solar sail, a piece of technology. But I don't think anybody else really believes that. And I'm one of those. I think, I understand why he proposed it, but then I think he was just hanging on too hard to the conclusion when other people came up with more reasonable explanations.
All right. Let's go to Kyla in Portland, Oregon. Hi, welcome to Science Friday. Hi there.
Hi.
Go ahead.
Hey. Hi. Yeah, so I guess the last question just kind of sheds a little light on this. I know you're talking about UAPs and UFOs, but my question was more, I guess, about our depiction of alien life forms in sort of our popular culture and just why we always have this notion that they're humanoid at all, why they resemble humans, why they have 2 arms, 2 legs, a torso, a head, why they look like us, and why not something completely out there, like why a UAP couldn't be an alien life form or something.
Like in Nope, like in the movie Nope. Yeah.
Exactly. That's what I brought up in my original call was Nope. That was like one of the most original depictions of an alien that I'd seen recently, and it just got me thinking that they could be any size, anything. So small, huge. Yeah. So anyway, that just is a thought that has been occurring to me lately.
Yeah,
so.
good question. Thanks for that call. And in fact, when people talk about alien life, the phrase that almost always comes up is flying saucer. But you tell a great story in your book about how that term came to be. It was a misnomer, right?
It was the greatest misquote in journalistic history. Yeah, so it was Kenneth Arnold was the first guy who, his story was the first big UFO story. And he was flying his private plane in Washington State. It was 1947. And he sees 9 objects moving the way he described it as being like the tail of a Chinese kite. And he landed and he told people about it. And then some reporters came and talked to him. And what he said he saw were things that looked like sort of crescent shapes, kind of like the bat wing ninja star things that, Batman throws around. They were crescents. But the reporter got it wrong and said he saw a flying saucer, a supersonic flying saucer. And within 6 months, there were 800 sightings of flying saucers, even though he never saw a flying saucer. So that really shows you sort of the power of narrative and story associated. That one of the aspects, I think, of you understanding UFOs as a phenomena.
Mm-hmm. But I mean, to the caller's question, when, this pervasive idea of what an alien looks like that we have in our culture, standing on 2 legs, has arms, right, has legs. I mean, do you think that's just persisted because we know what we know and we're not using our imaginations?
I think it's because of low budgets on science fiction films. It's a lot easier to slap some antenna on some guy's head and call it an alien. One of the most fun parts of the book was when I sort of went did a deep dive into evolutionary theory and asked, like, well, what do we know about Darwinian evolution that'll tell us how life can evolve? And it turns out that, yeah, some things, there's what's called convergence in evolution, that evolution will use the same tricks to solve similar problems of, like, how to walk around on an air solid interface.
Right.
So you might expect legs and you might expect heads, but you're never going to get the same combination that you got here. There's also, evolution is about accidents, just as importantly, contingency. So we should expect with aliens, we should expect to be surprised and probably grossed out a little bit. It's not going to look anything. We're probably the only humanoids in the galaxy, if not the universe.
Maybe shift our thinking more to the blob than the grays.
Blobs are good. Yes, goo. I'm into goo.
It's a goo. Primordial goo or just goo in general?
All kinds of goo. I think, general, like you look at life on Earth, if water is really important for life or any kind of solvent, then you should sort of expect things to be amorphous. And, the idea of blobs or goo, that could be something that's used quite a bit, as life's architecture.
Yeah, well, they talk about having to have a precision grip to make tools and things. The goo would have to find a way to do that. And we're going to talk more, but we have to take a break. We're going to talk with Adam Frank more about his book, The Little Book of Aliens. And Adam, when we come back, I want to talk about where you think we could search for aliens in our universe, and especially about the whole idea of these exoplanets may have, right? And what do you look for on an exoplanet?
So let's talk about exoplanets, because your idea is that, better than looking for alien life on our planet, we should start looking for it on other planets. And a good candidate for that could be exoplanets, right?
Yes. I talk about in the book about these 3 revolutions that have happened in astrobiology that now make it a really going concern that NASA is all in on. And the first of that was the discovery of exoplanets, that the universe is teeming with worlds.
And what would we look for? What would be the signs we would look for? You talk about some Dysonian things like circulating giant satellites around planets, right? Or electrical solar panels, or even just the biology of what's going on in the atmosphere.
Yeah, that's really the exciting thing. So what was not possible beforehand and is now finally possible is that when we detect exoplanets, one of the main ways we do it is when the planet passes in front of the star. We call that a transit. It's like a little eclipse. And if the planet has an atmosphere, then some of the starlight passes through the atmosphere, gets a chemical fingerprint of what is in the atmosphere. So we can, even if it's 40 light years away, we can tell what's in the atmosphere. And so that means we can tell whether there are chemicals in the atmosphere that only life would put there. So, for example, oxygen, take a deep breath. The oxygen in Earth's atmosphere is only there because of life. If life went away within, not too long a time, all that oxygen would react with the rocks and disappear. So oxygen, and particularly methane, if you found them both, that would be a strong indicator of an alien biosphere. So so the oxygen is a biosignature. Likewise, there are techno-signatures, signatures of technology, things like chlorofluorocarbons. Our group, I'm the principal investigator of NASA's first grant to study these techno-signatures in planetary exoplanet atmospheres. And we showed that chlorofluorocarbons are something that even the JWST could find. So that's an example of a techno-signature. City lights, we would be able to detect city lights, artificial illumination on a distant planet, or solar panels, if there was a large-scale use of solar panels. So all this science is just happening right now, but it shows you that finally we're ready now to start getting data that will show whether there's life or even intelligent life on other worlds.
We have a question from Steve on Twitter. On X, I should say. And Steve says, isn't it possible that there are other life forms in the universe that aren't carbon-based like us humans? Therefore, they wouldn't necessarily need to live on a planet located within the Goldilocks zone. What do you think of that?
Yeah, we've had a few of those questions coming in. Lots of people asking that same question.
Well, that's a great question, and it really shows you how mature this field has gotten. Because, again, when I was a graduate student, nobody really was studying life in the universe. There was no way to do it. It was still there was what we called the giggle factor associated with it. But now, NASA's been funding this for over 30 years, or at least 20 years. And so the whole field has had a chance to mature so that now we are agnostic. We're learning how to do agnostic astrobiology, where we're not saying, oh, it's carbon-based or its molecular chemistry, biochemistry looks anything like ours. And we're looking for much more general ways of thinking about what life is and what life does. So, for example, we don't really need it to be carbon-based. It could be silicon-based, and we can figure out what the properties, say, with the atmospheres. I was talking about atmospheric biosignatures. You don't have to necessarily look for something associated with carbon. You could just look at the chemical reaction network, which if that network, which is basically which chemicals react with other chemicals, life makes very different chemical reaction networks than non-life. And you should be able to tell that, whether it's carbon-based or silicon-based or whatever. So the idea of agnosticism is really the frontiers of astrobiology right now, and we're really making progress with that.
Uh-huh. Let's go to the phone. So we've lit up the phone. Let's go to Kim. And is it Tallahatchie, California? Or give that to me correctly.
Well, my name is Ken.
Say the whole thing wrong.
And the town is much harder to pronounce than that. It's Tehachapi.
Thank you. Thank you, Ken and Tehachapi. Sorry, go ahead.
Well, I just thought you might be interested to know that I'm so old that when I did my master's thesis, it was about 50 years ago, and my field was not in science. My field is international relations, political science. So I had a bit of a hard time talking to my professors into addressing this issue because they were they were absolutely immersed in the giggle, as you call it, the giggle factor. But I was able to finally persuade them, and so I wrote the paper on, as of 1970, the international implications of contact with extraterrestrial intelligence.
And what did you have a conclusion in your paper?
I did.
What was it?
And of course, I had to really get into all the science because the perceived contact might be a perceived malevolent, might be perceived benevolent, or perceived we don't have a clue. And it might be just, contact with a little blob of bacteria. So my professors I think they wanted the interesting factor. So they wanted to have a perceived, probably malevolent, and contact on our planet.
Thanks for that call, because we have other callers with a similar vein. Somebody saying that Stephen Hawking said if we hear a signal from ET out there, we shouldn't answer it because it could be waiting, to serve man, as the old Twilight Zone said.
I love that. Best episode ever.
So what is your answer to that? What do you think the ramifications of not just finding intelligent life, but any kind of life?
I think it'll be and this is the sort of I was kind of wrap the book up because I really wanted people to understand. I don't think it matters whether it's intelligence or not.
You don't. Finding
any kind of life would be the most significant scientific discovery in the history of humanity. And the reason for that is life is weird, right? We know a lot about, what physics does. It makes black holes and it makes comets and it makes planets. But life is unlike any other system because it creates, it evolves, it innovates. And as of right now, it's possible that this incredible innovative capacity was a one-off. Like we're the only time in the entire history of the cosmos that it happened. If we find just one other example, then really there's more examples. Then probably life is common. And that means all bets are off because life can innovate because it can go past itself. Like what life can do, and we're part of it, becomes almost, sort of entirely, infinitely open-ended. And it would show that we are part of a cosmic community of life. And I think it would really force us to reevaluate how we see ourselves and how we see our place in the universe. And just to make the point about why it's important, think about the Copernican revolution, which was just, a scientific discovery that, oh, hey, the Earth goes around the sun, not the other way around. That was implicated in the Renaissance, in the Enlightenment, in the Protestant Reformation. It was just an astronomical idea, but it actually helped reshape world politics.
Do you still find that there are barriers for astrobiology to be taken seriously within the greater scientific community? Despite the fact that it would be just incredible if we did find evidence of life elsewhere.
When it comes to what I call dumb life, and I mean no disrespect, but when it comes to biospheres and microbial life, no. I mean, NASA's next giant telescope, the thing that's going to replace the JWST, its name is the Habitable Worlds Observatory. right? So that shows you that we are all in. The entire astronomical community is saying this is the number one problem for astrophysics. When it comes to intelligent life, I still find, my colleagues and I on this NASA grant still find that we have to, especially sometimes for older scientists, there's still that bias. There's still that giggle factor. But it's slowly dying away. The fact that we got this grant, which really NASA got so burned by Congress for doing any kind of SETI work back in the 80s that they were kind of like, we're not going to do this. The fact that we even got this grant shows that the tide is turning.
Okay, let's go to see how many calls I can get in. Colleen in Pensacola. Hi, welcome to Science Friday.
Hi, thank you.
Go ahead.
I have a question based on the conversation. I have totally enjoyed this program. If I understand proof, but what do you say to the people who say they have been abducted and have drawn pictures of the people, of the beings that have taken them? I mean, are they delusional, or how does the author feel about this?
Good question.
Well, I would never tell somebody that they didn't see something they said they saw, because I wasn't there, right? But science is about public knowledge, not private experience, right? And so if we want to have public knowledge, something that we can all agree on, then we need the same kind of standards of evidence that we use to, say, make our cell phones, right? The reasons these cell phones work and are not just like a brick that we hold in our hand is because of these incredibly rigorous standards of evidence that scientists have. Scientists are so mean to each other about their evidence. But that's what's required for us to be able to say that as a community that we know something. And so, for people who have those experiences, there's nothing I can say, but I can't do any science with it. And that's really the question.
One of the famous lines from the X-Files TV show was, "I want to believe." Do you think we as a culture want to believe that we're not alone?
I do, because we are the cosmic lonely hearts. It is very strange to be a human being and have this capacity to know what the stars are, to know how large the universe is, and then have no one to talk to about it, right? I mean, human beings, first of all, we're terrible to each other, right? And we have this thing of like, does anybody do better? And so we have all of these deep questions about ourselves, and we don't have anyone to talk to. So I think naturally we look to the stars, and now that we know the stars are just like the sun and that there's planets all over the place, we want to know what other stories the universe has written with creatures like us.
Knowing who to talk to, that's the subject of Alex in New York. Welcome to Science Friday.
Yeah, hi there. So my question is basically, it's hard for anyone to agree on anything from elections to climate change. So it's not clear to me that if extraterrestrial life was found, everybody would agree that it was.
Great question.
From the perspective of the aliens, who do you pick as your human spokesperson to convince the most people?
That's like,
Is it Oprah?
Yeah.
Is it Lionel Messi?
Dwayne "The Rock" Johnson.
I've always wanted to say this, so I'll take my answer up the air.
Yeah, you got the ability to say that now. That's what happened, in science fiction movies. They go, "Take me to your leader," right?
Right.
So, is there any one person who would be good? That's a fun question.
Dwayne "The Rock" Johnson.
Because
that's who I vote for. He'd be great. I mean, he's a nice guy. He's huge. I think that would be the right representative.
All right, let me ask you this question. I'm going to give you the blank checkbook question I give a lot of my experts who come on, and that is, you're talking about investigating, looking for signs of life, let's say in the exoplanets. You talked about new methodologies that are coming on, a new telescope. What tool, besides that telescope, could you love to have if you had an unbelievable amount of money to spend on it?
Well, more than one telescope in more than one wavelength. I'd probably want, a bunch of those telescopes that are configured in different ways to, because this is the problem with building a telescope like this. You have to sort of, you have to look at all the possibilities and then somehow, roll the dice on the best bet. So if I had lots more money, I'd be able to sort of put my cards down on a lot of different bets. I would also want probes in the solar system. I mean, there's a lot of really interesting places in the solar system. The ocean moons of the giant planets. Like, for example, Titan is a really interesting place. I'd love to have boots on Mars looking for either existent microbial life or fossil microbial life. So there is just so much that we could be doing. And we're just, we're getting, even though it's, a space telescope's a lot of money, it's still a little dribble compared to what we could be doing.
But how do you cope with just how vast space is? I mean, even if we did find a spot that had some sort of techno-signature from another place, it would basically be impossible for the technology that we know about to get in contact with them. I mean, let alone visit, right?
Well, I think, imagine that we do, let's say we find a techno-signature on a star, a planet orbiting a star 10 light years away. I think what would happen is we'd then build the next biggest telescope to get even a better view, and et cetera, and we keep doing that. And at some point, we'd send probes, and the probe might, if we could get something up to half the speed of light, it would take 20 years to get there and 20 years to beam back. But it shows you that we got to be in this for the long game. I think this would just be the beginning. It wouldn't be the end of the story. It would be the beginning of a long, long story.
Are we in it for the long game? Is there enough money, interest to be in it for the long game? Have things changed now?
I think so. I mean, the fact that the next JWST is the Habitable Worlds Observatory shows that we're willing to put enormous resources into it. And if we find something, then I think really then all bets are off. You're going to see an enormous amount of funding poured into that if we get our first good bio or techno signature.
You like to quote Carl Sagan in your book a lot. And
I do.
Especially about evidence, right? Extraordinary.
That extraordinary claims requires extraordinary evidence. Absolutely.
Still true.
Absolutely.
And what kind of evidence would that be? Extraordinary. I only got about a minute left, but what kind of evidence would you need?
We would need, for example, if we found chlorofluorocarbons in an alien atmosphere, that would be it. You can't make chlorofluorocarbons unless you have industry. So that right there would tell you that planet has an industrial, intelligent civilization.
That's terrific. It's a terrific book. My guest is Dr. Adam Frank. He's the Gowan Professor of Astrophysics at the University of Rochester, author of The Little Book of Aliens. It's a great book, Dr. Frank. It's just
Thank you.
well written. I recommend it to everybody. Thank you for joining us today.
Thank you. This was so much fun.
And we have an excerpt of the book on our website at sciencefriday.com/aliens.